Okay, today we're going to talk about the area of parallelograms. If you remember, we kind of touched on what shapes were and what a parallelogram is, but we're going to go ahead and write our topic today, 12.5, area of parallelograms, our I can statement. I can find the space inside, or otherwise known as, we know it's the area of a parallelogram. A parallelogram, just to review that, it means that it's a shape, closed figure. It has four vertices, and it's going to have two sets of parallel sides. Remember, all parallelograms are not slanted like this. It could also be like this, which we call a rectangle. It just has to have two sets of parallel sides. It could also be this. Well, we talked yesterday about area of these shapes are length times width, same as with a square. But sometimes these parallelograms are slanted, and as you can see, meaning they're not 90-degree angles at the corner. So right here, this is definitely an obtuse angle, acute angle, obtuse angle, and acute. Well, when this happens, we have to make sure that we're not just doing length times width, and we're not just taking the length of the side times the length of the bottom here. So they have a similar formula to length times width. It's going to be, we need to know these different words. So base is the first one, and the base is going to be the bottom portion of the parallelogram. Well, with this square, or this rectangle up here, this would be the base. With this square, this would be the base. So whatever's sitting, I guess you could consider what's the furthest side that's towards the end of the paper. Because then we have to know what the height is, and this is when this slanted parallelogram or parallelogram that does not have 90 degrees like a square or a rectangle come into play. Our height of a parallelogram is from one of the vertices connecting to the base. Notice this is a dotted line here because it's not actually one of the sides. It's a dotted line because it's just a line that's drawn from one of the vertices to the base to make this 90-degree angle. And so the area of a parallelogram is going to be base times height, but very similar to length times width to get the space inside of this parallelogram. If you could imagine, we could cut this piece off right here and move it and put it right here. And if we did that, we would have a perfect rectangle like before. But if we try to use the side portion of the parallelogram as far as, okay, I'm going to use that to get the length of my parallelogram, it will not work. It'll give you funky numbers. So, all right, so let's go ahead and put this into practice. That formula, again, remember, is base times height. Well, we have to know what the base is. So if we look down here at the bottom, from this corner, this vertice to this, this vertex to this vertex, it says, it has this label on it, 8 inches. So we're going to plug that 8 in for our base. Now, there's something important you have to look for. Sometimes they're going to be tricky and try to put a measurement on one of these sides. But remember, we don't want to use those sides. We want to use the point that goes from this vertex all the way down to the bottom and has this little symbol here to show that's a right angle. So this one is 5. So we plug that in there for the H. That's the height. And then we just do some math. 8 times 5. And last but not least, what we talked about yesterday, put a label on it. Is it elephants? Is it light bulbs? Is it cups of coffee? So we put inches on the end there. And because we're finding the space inside this figure, we have to put that squared on there. Some of you said, oh, okay, well, I'm going to use the SQ squared inches or inches squared. Either one of those is okay. All right, here's another one. Your teacher tried to draw it the best she could. Here you go. We want to go ahead and do our formula is base times height. And so we're going to find what the base is. Well, the base is down here, and it has this label on it of 4.5 meters. So we're going to plug that in there for our base. And now we need our height. Look, we have two numbers here. We have a 12 and we have a 10. Which one of these two numbers are we going to use for this height? I hope you said that we're going to use 10 because that is the one that connects from the vertex all the way down to the base and gives it a right angle. So we put the 10 in there, and then we have to multiply. Whenever we multiply by 10, remember, it's simply moving the decimal. If we're multiplying by 10, we're getting bigger. So this decimal is simply going to move one spot because there's 1 0 here. If you would like to, you can write it out. 4.5 times 10. But I'm telling you, it's just going to move the decimal. It's okay. You can do this too. There's no harm in it. Ain't no shame. So our answer is 45, and we want to make sure that we put a label on it, and we square that label because we're doing area. With this formula information, you're going to be able to take some numbers and be able to plug them into the formula and be able to find missing numbers. Yes, this is kind of algebraic, yes, but we've practiced it. So we're going to find some missing numbers here with the information. We don't even have a picture, but we can use this information to figure out the height in this situation. So we're given the information. The area is 42 inches squared. The base is 14 inches. And we know our formula over here is base times height equals A. So what I'm going to do is I'm going to substitute these numbers in for these letters. So I'm going to keep the 42, or I'm going to put the 42 in there for area. I'm going to put the 14 in there for base. And I'm going to keep the H because I don't know what it is. I'm going to keep that variable in there. It could be any number, but it's got to make this be true. So if I could do a couple of different things, I could do a guess and check, throw some numbers in there and see what might equal 42. Or I can do the opposite of multiplication on each side, which is division. Remember, if it's over, if we have a line like that, like a fraction, it's going to be a division problem. So this is bigger than the 14, so it falls into the house. This over here, 14 divided by 14 equals 1, and we know that 1 times h is going to be h. Over here on the side, I'm going to do some division. Well, how many times can 14 go into 42? Yeah, you might have to multiply it out to the side. That's okay. Go ahead. Well, it's more than 1, I'll tell you that, because 14 times 1 is 14. I can do some multiplication out here. 14 times 2, well, 4 times 2 is 8, and 2 times 1 is 2, so I know it needs to go another more than that times. So I'll do a little extra here. 14 times 3. Ooh, we might have a winner. 4 times 3 is 2. 3 times 1. Oh. 4 times 3 is not 2, it's 12. I forgot to carry my 1. 3 times 1 is 3, plus 1 more. Look at that. We have exactly 42. So I put my 3 up top. I put my 42 down below. Subtract. And I know that my answer now, h, equals 3 inches. Because I could put that 3 back in there for that h right here. And it's going to make this true. It's going to make it say, oh, okay, well, 14 times 3 is 42. It makes it be true. All right, so go ahead and Open up Schoology, grab your assignment. Some people were asking about the secret number. The secret number was 954, and I had some people guess that one. We're going to start a new secret number today. Your first clue is that the number is between 1 and 200. That is your first clue. So you might as well get started guessing. Happy mathing!